This unit will discuss probability. We'll first start off by talking about some terms that we use in probability. A probability experiment is an experiment in which possible outcomes are known, but we don't know which particular event will occur. So in a probability experiment, we're able to associate some kind of probability to an activity or to an event, and from there, we leave it up to random chance. Now, the event that occurs, or what can occur in a probability experiment, is called an outcome. And an outcome is the result of a single trial in a probability experiment. If we collect all of the outcomes that are possible, we get what's known as the sample space. And we generally write the sample space using notation like this. Call it S, and we use the brace. And we list all the possible outcomes. We close it. If we are interested in a particular outcome or particular event that can occur, we're talking about an event. And an event we write like this. It's the probability of some event E. So the P stands for the probability of an event E. So here's an example. Let's say we roll a fair die, and I want to identify the outcome, sample space, and event. Well, the outcomes of rolling a fair die is you can roll a 1, a 2, a 3, a 4, a 5, or a 6. Those are all the possible outcomes. If we list those possible outcomes, we get a sample space of S equals 1, 2, 3, 4, 5, or 6. An event is any specific outcome that we're actually interested in. In this case, let's say we roll an even number. Well, that would be 2, 4, or 6. Or you roll an odd number, 3, 5, or 7. Or you roll a number that is, for instance, if I write this, the probability that, we'll call the event E. And we'll say the probability that E is less than or equal to 3. Well, that would be events 1, 2, and 3. We can list all of the possible events and all outcomes that are present in what's called a probability tree. And a probability tree is just a visual way to represent all possible outcomes. And what generally happens is these events or these outcomes are independent. And we'll talk more about that later, but independent just means that one event will not affect another. When I generally start teaching this class or show people probability, I have two individuals play the game paper, rock, scissors. In the game paper, rock, scissors, the events are independent of each other, which means when two people play, a person throwing rock should not affect another person throwing rock, or should not affect another person throwing paper, or another person throwing scissors. So from this, we get what's called a probability experiment, because each outcome has a probability associated with it, but it's left up to chance or until the people actually play. And so here's how we can look at this. We're going to create a probability tree, and we'll let the first throw be the first person playing the game. So the first person playing the game can either throw a paper, a rock, or a scissor. Then if we look at the other persons playing against these, if the first person throws paper, then the second person, whose events are independent, can throw paper, rock, or scissors. If the first person throws rock, the second person can throw paper, rock, or scissors. If the first person throws scissors, then the second person can throw paper, rock, or scissors. And now we can list out all the possible outcomes. Well, the outcome is the actual thing that's going to occur here. So, and we're actually interested in whether a person win, loses, or tie. Those are going to be our outcomes. So, for instance, if the first person throws paper and the second person throws paper, you get a tie. If the first person throws paper, the second person throws rock, you're looking at it from the first person's point of view. Paper covers rock, so this is a win. Paper, then scissors, this is a loss. Here are the possible outcomes. These are your outcomes. Now, next one. If the first person throws rock and the other person throws paper, this is a loss. Rock and rock is a tie. Rock and scissors is a win. Scissors, paper, win. Scissors, rock, loss. Scissors, scissors, tie. If we want the sample space, S, that's equal to, when you get tie, win, loss. The next one you get loss, tie, win, and then the last set you get win, loss, tie. Well, how many outcomes are there in the sample space? There are 9 outcomes. And we can set an event like this, then the event becomes the probability, let's say the probability of a win. So we say the probability of a win. This is an event. It's looking at a specific outcome. The probability of a win is, and the probability, it works like this. How many outcomes are there total? 9 total outcomes. That's the denominator of the fraction. How many result in what we are actually interested in, which is the win here? That's 3. So you get 3 out of 9. We generally don't reduce probability, but you could call this 1/3. The question I would ask is this a fair game? Where the word fair means that each outcome is equally likely. So if each outcome is equally likely, the probability of win is 3 out of 9. The probability of a loss is also 3 out of 9. And the probability of a tie is also 3 out of 9. So in this game, are the events equally likely? Yes, it makes it a fair game. But this right here is a probability tree, and it lists all of the outcomes possible and each event that you can have in this area.